Greetings, welcome to day 78 of projectDIG. Thanks for joining. projectDIG is a 2D automation survival sandbox game that I am developing entirely here on Twitch and uploading the VODs to YouTube. So we're making a custom game engine here, and right now we're working on Cellular Automata. And that's used for the liquid simulation, water, lava. Can also be used for other things such as temperature, gases, pollution, I don't know, like a bunch of things. projectDIG is going to be kind of not just a automation sandbox game, but kind of also a simulation game. And so this is a very important feature of the game. At least I think it will be. So we've been working on that, trying to get it to a good state, and we're getting there. We are definitely getting there. It's complex code, to say the least. I'll run it here. I think it's still working. I don't think I've broken anything. And I'll show you what we got right now. Yeah, I think it's working except for there's like one or two little issues with it. Namely with how the flow is working. So you can see, the water, it's kind of spreading out. We have a bunch of numbers to help represent like the values of it. You can see like it spreads out pretty well. We do have an issue where it kind of stacks off to the side. So like it's always going down to one of the sides. So here's, it's slowly, yeah, there it goes. 6, 5, 4, 3, 2, 1, which really shouldn't happen. Like it should evenly just divide all of those, and like they should all be, 2 or 3 or something. Like that should be a 3. Yeah, probably like a 3. So that's because of the flow that we've been working on. And that's what we're going to be doing today, is trying to get the flow to make sense and work and be happy. We'll see how that goes. Looks like that is still going higher than what I want. Let me fix one thing here, which is probably over. Yes, here we go. Okay, so we just want to pick the minimum value between those two. What's happening right now is you can kind of see, it's a little hard. Oh, that looks really cool. It reminds me of Korea's water a little bit. Yeah, it is similar to Korea's water. There is two big differences that I'll kind of show off. But you can see how like this is stretching down. It's because this is 21 and like this one is 20, so they're supposed to be square. But yeah, so I just needed to cap the size so that way the height is always, well, they're not completely square. They never exceed 16 though. So one of the differences, if that this has over like the Korea water simulation, is that it has this concept of pressure. So you can see how like it's actually a little broken because of things. Like you can see it's like 18, 17. Yeah, I need to fix that. You can't really see it right now because of this. What's supposed to happen is that it's supposed to be moving the liquid over, but it's not. Like if this was a smaller container, like I think we might be able to do it like that. Does that work? No, I guess not. Yeah, it's broken right now. It was working before, but it's messed up now because of how the flow is. But what's supposed to happen is that it's supposed to kind of spread the liquid out, and as it gets deeper, it is like compressed more, so you can kind of see. I don't know why these are jumping over here. That shouldn't really happen. But you can see like these are 19, 18, 17, 16. And so this will change like the pressure. And so it allows it to like kind of have more quantity in it as it gets higher pressure. And that allows it to kind of like try to equalize out if there's like an escape kind of. But it's broken right now because we're trying to implement flow, and flow is the concept of being able to have a liquid have like some concept of momentum and moving in a certain direction, and then being able to interact in various ways. Like maybe if it has a really high flow, then it will move in a direction at a greater speed. So like right now, whenever, and I've been using this stuff to kind of illustrate various ideas, but right now, if we have, actually maybe we will go back to this. If we have two tiles next to each other, let's just say 3 tiles. So this has a quantity of 10. Let's say this is only 5. And this is 6. Typically what you would want, like you want water to, eventually equalize. And so without flow, what it would just do is try to divide all of this. It would say, well, this is 21 total liquid, so let's just make it so that they're all 7, and then it's even. But if you have the concept of flow, then suddenly you might not want to just equalize it out. If you have flow going in this direction where you're like, hey, there's like the water's moving in that way for some reason, maybe it's not going to be equal. Maybe what you're going to want to do is something like say, oh, this is now a 9, and this is 6 and 6 or something like that. Or hey, there's a really high flow. Now this is 10 and this is 5 and this is 6 still. Or maybe they're like I guess maybe what would make more sense is like 11 and 5 and 5 or whatever. It really depends like on the flow of this thing as well, whatever. But yeah, so that's how we can kind of add in this concept of flow. And so then, if it hits up against the wall, and this is, I was kind of talking about this yesterday. Like if it comes up against the wall, let's just say there's a wall right here. Then what could happen is that it could actually like go up the wall some. So it could say like, hey, if there's a lot of liquid here, maybe it starts stacking up. So this becomes like 19, and since it can go upwards, maybe then it gets split, and so now it's instead of 19, it would be 3 and 16 or something. Or maybe if you really want, like if it hits up against a wall and there's ground beneath it, maybe we could give it an upwards force, and instead of being like, it could be 19, or it could be something like maybe 9 and 8 or something. So it actually like is kind of being pushed up against the wall. trying to convey that nicely might be a little tricky to do. That's mostly with like graphical stuff, like you would want it to kind of like go up against the wall like that. Yeah, it's a little, that might be a little hard to try to convey, but we'll start with just getting some flow working. So I have this concept of flow working, I believe, for downward momentum, like it gains speed as it falls down. And I was trying to yesterday figure out how do we make it so that we have this concept of flow moving to the left and right. And I was trying to get that to work and it was not working. One of the problems it's not working is I think because as it moves to the left or right, it slows down, which isn't that bad. But the problem is that once it has slowed down all the way, it will stop flowing. And that's why we are seeing that where it will be like 15, 14, 13, 12, 11, 10, 9, 8, like where it just is like slowly going down one by one by one, because once it has slowed down all the way and it has no more flow, or once the flow is less than 4, that's the absolute flow, then it will stop giving the extra quantity. So if there's like one tile with 12 and one tile with 13, normally it moves that extra quantity, the remainder, over to the neighboring tiles. So that way it tries to like, spread out as much as possible, and you don't get that like staircase of slowly decrementing the quantity. But yeah, once that slowed down, the current cell keeps the extra remainder, and that's a problem. We do want to do that kind of, because if a cell is if it, what will happen is that if we don't do that, eventually it will ping pong back and forth between the two tiles where they share that extra quantity, where it's like, oh, this tile now has 12 and this one has 13. And then the next simulation generation, it swaps them. And so it's 13 and then 12. And then it's 12 and 13. And so on. And it just keeps going back and forth. And they never come to rest, which is kind of a problem, because we want them to eventually come to rest. So that way we can stop simulating that, because it's a lot of work to like have to go through all of them and be like, oh, hey, this needs to be updated. Oh, is this moving this back over there, whatever. And so what I'm thinking we can do is, instead of having the liquid flow slow down every single time it moves, maybe it only slows down if it comes in contact with a tile that has maybe only the opposing flow, and they kind of can negate each other to some degree. Maybe also like, maybe what it could do is some sort of negation where like they actually do negate each other, but also some of the power is transferred to be an upward momentum. And then they fall back down. And so that way we could have it kind of like, if we have two, like if we have two flows coming at each other and they both have fairly high flow, then whenever they hit each other, they can splash up, which would be cool to actually like be able to do that. And so we could do that with the upward momentum, upward flow. So yeah, how can we do this? Let's work on that. So what I think we can do, like I was saying, is have maybe like combine the left cell flow X. We don't want to completely combine them because that would like, if they're flowing in the same direction, it would make it so it goes even higher, right? Which we don't really want. Maybe what we want is something like the maximum between the two with addition. Yeah, that's. I think that might make sense. Where it's like the self flow X plus the flow X. This only really makes sense if they're opposing signs, right? Isn't there a way to check that? C++, share sign, number, share sign. Is it just sign? Sign bit. Returns whether the sign of X is negative. I feel like there's a copy sign. Check if two numbers have the same sign. I think I remember looking at this before. Yeah. I was just seeing if we could, like this works as well. I was seeing if there was like a nicer way where we don't have to do multiple comparisons. Because this, we're having to do a check to see if x is less than 0, and then a check to see if y is equal to 0, and then a check to see if they're equal. So it's like doing 3 checks, but it'd be kind of nice to just do 1 check. I feel like there should be a way, because we should be able to just get the sign bit and then compare those, right? Like, the sign bit's always the same. It's always the last bit. I don't know, I don't get that. Like, why we can't just do that. Math.sign. I mean, I guess we could try that. I wonder what math.sign, I mean, just the sign function actually does. Sign bit. Like, this is, I guess, really what I was thinking. Maybe this works, sign bit, but that's for not integers. I don't want. Copy sign is slow, especially if you need to promote and then narrow again. Huh. I didn't know that copy sign. There's -1 for and positive ones. Yeah. Wonder what copy sign does and why would it be slow? To result in extra code for me in the FPU. Huh. Yeah. Okay. Now, I was just wondering what would be the best way to do this. So we could try to add them and get the minimum value between these two. That doesn't quite work, right? Because that's, if they're both negative, I want like the absolute value. Yeah, I think what we need to do is basically check the sign. And I might have this in the math because I had looked at this before. I don't know, maybe not. Where is that? Oh, I guess I got rid of the math. Oh, it's probably in utility. There we go. It's empty. Pop count. Okay, maybe we'll add one of these checks in here. Well, not checks, but sign bit. Yeah, I don't want that. I don't think I can do a const expression. Wondering. I guess what we want is a bool. Same sign. Doesn't make sense to have it be a uint, right? Value 1, value 2, and so yeah, it's just value, compare it. I mean, it doesn't matter which order we check. We could say, hey, if it's greater than 0. So one thing is like, what about 0? Do you want to count 0 as positive? Or I guess you could say that. So you could say greater than or equal to 0. And then value is value 2. Whoops, value 1, value 2 is less than 0. So that works. I don't, yeah, we'll go with this for right now. If they have the same sign, that is these two, then we want to just take whatever one is larger and assign that to the left cell. Flow x is equal to the maximum between those. Otherwise, what we want to do is subtract them, right? from one another. I don't think we want to. Oops. So if we do this, oh, they're not the same sign. Wait, whoops. Let me fix that. I have a math util as well. I don't think so. They have the same sign. I want to add them if they have the same, if they don't have the same sign, because if they don't have the same sign, then that means one is positive and one is negative. Their code is intense. What's up, Grizzly? Yeah, we're doing some complex stuff here with the cellular automata. Okay, so now that we have the flow combined, so they are potentially completely negating each other. You know what? Now that I think about it, we always want to get this value. I guess it doesn't matter. We're going to be branching here. But what I think we want to do is take the maximum and divide it by 2 and set that as, or like add that to the positive flow. So the left cell, yeah, I think that's what we want to do. The left cell flow Y should, no, it would be negative because we want to have it go upwards. Positive is down. And then I think this left cell flow, they're hitting each other. Stop hitting yourself. Maybe what we want to do is, do we want to always have them override one another? I mean, I guess we could do something like that. Where if, let's say you have one flow that, like, if this is 30 and this is 70, then you would think that, like, whenever they come in contact, they will maybe, like, hit and splash and it'll almost, like, create a wave, right? But it would go in this direction because the 70 is much stronger than the 30. And so I think that makes sense. So we get the maximum between the two, so it would be like 70 in this case. And then we divide by 2, so it'd be like 35. So now we're saying, hey, add 35 for it to go upwards, but also have it still going in this direction at like 70. I thought that we have the same sign. Yeah, there it is. I don't know what's going on there. And so I think what we want to do is then say that they're both 40 going in that direction. So at that point, we want to say, hey, we have the left cell flow x is equal to flow. And I just realized what we can do is this. We don't have to set both. Maybe we want to also do the same with the right cell. Flow Y, or I don't know actually. Maybe. But I don't know if we actually want to completely override it. I don't think so. I think what we'd want to do is probably calculate this. 32t. Flow Y. And then Do that, and then get rid of this. So crazy. Okay, I think that's okay. We can try this out. And so this needs to happen in right here. The difference is that we don't have a left cell, we have a right cell now. Oops. I wonder if it'll must be, whoops, that's wrong. This needs to just be cell. So, why did I put right cell? So wrong. In this case, if they're both the same, then it just picks the max between the two. I think that makes sense. I could almost see us wanting to do that. This, where we take the average between the two. Does that make sense? I don't know. Let's try that. Hey, Steve Void, what's up? I am guessing it's not happy about the same sign missing. Did I not put it? Oh, whoops. I kind of didn't mean to put the implementation right there. But why is it not working? I have math right here. Oh, I think it's supposed to be utility math. There we go. Yep. Had the include wrong. Alright, so we will try this to see how it works. I might need to change the numbers to be able to, or do something here so we can see the flow. Visualize it. Let's see how it spreads out. Why is it doing that still? So whenever it hits the ground, oh, we're not, oh, we don't set. Okay, that's true. That's our problem. It's falling, and whenever it hits the ground, we don't give it any sort of flow. So one thing we could do, I think, like just quickly, is maybe something like this where we say, hey, let's take the cell, or like, okay, so this is dividing it between the two, right? I think what we want to do is say, oh, we have the absolute value here. I don't want that, actually. I just want to say, what? If the flow x, maybe we do want the absolute value. I don't know about that. Let's try this to start with. We'll say if the cell flow x is greater than 0, or actually maybe we want to say it's greater than like 8. No, we'll say 0. Yeah, if it's greater than 0, then what we'll do is we'll set the left cell, or maybe not set, but we'll add to the left cell. Oh dang, I want this to be flow y, right? So if it's falling downwards, we want to, and it hits a block where it can now like spread out. what we want to do is take that downward velocity and have it move over. And we actually need to do the same here as well. Yeah, where we just like basically need to transfer that downward velocity to like, so the vertical velocity to a horizontal velocity. Hey Faye, what's up? So yeah, we kind of need to do that in all of these places, huh? Yeah. Kind of feel like this code is getting complex enough that it might make sense to factor this out into another function or something. Because these are almost the same. Is this like changing the left and right stuff? So we have like the left index and the right index, and the left cell and the right cell. And besides that, they're pretty much exactly the same. I think so, pretty much. So what do we want to do? We don't want to change the quantity. We want to say if the flow is greater than 0 and it's trying to spread out, then what we'll do is we'll take the flow. I think we might want. Maybe take half of it. Whoops. We'll just divide it by 2. It should optimize that. And so for the left cell, we want to say it's negative. So we're going to basically subtract the flow y divided by 2 from that. And then for the right cell, we want to add to it. And I don't really know what we want to do for the cell that hits the ground. I guess we kind of want to, if it hits something. Maybe what we want to do is also just slow it down. So say cell dot flow y is negated by half of the flow y. We know it's a negative number, so this will cut it in half basically. Wait, that makes sense? It cuts it in half. Can we just divide by half, right? Maybe that makes more sense then. If we divide it all by half, oops. Then we could just subtract the flow y. Then we don't need that temp variable. That's better. Okay, I think that makes sense. So this will actually give us flow x, because before we didn't have any sort of flow x. And so, yeah, like, we need a way to generate flow, right? Like, as things move, it's generated. And how we typically have flow happening is from gravity, where gravity is pulling it down, so we generate flow y by it falling, and then whenever it hits the ground, that vertical flow is converted into horizontal flow. Let's see how this looks. It's kind of capped out over here. Oh, this is weird. Okay, so that broke things. Why is that? That's weird. This isn't working at all. You know what I think I need to do? Well, like that's working. We're like kind of nicely spreading that out. This is still toggling. Like we don't want that. Okay, so here's what we're going to do. Yes. This will help. So we're going to change this. So instead of drawing the cell quantity, what we will do is we're gonna maybe yeah, we'll do this. We'll go to the automata liquid component, and we're going to add in a new thing here, which will be the data representation liquid data display. Maybe we'll call it that. Display quantity, liquid quantity. Oh wait, what am I doing? Display, maybe we'll say display mode. Display mode is equal to liquid quantity. Okay, and then we'll go up over here. Actually, let's put it here. Okay, so we'll say quantity mode. What's the other ones? Quantity, flow X, and flow Y. Display mode. Okay. So that should work. And so now what we're going to do is take this, say liquid component. This is the liquid component data. But then down here, what we want is to have, I guess we don't need to have it be a conditional, right? Well, we can set up the font color. Text.color. We can just have it be a switch, I guess. Hey, Mr. Wormhole, welcome. Switch, liquid component, display mode, and depending on the display mode, we're going to have a different color. Whoops, that's case. What do we want? Quantity. What is this? Liquid display mode. Quantity. Color should be, maybe it's just white, just by default. And flow X could be kind of a red tint, and then flow Y can be RG, yeah, green. Okay, so that will set the color. And maybe the one thing that sucks about this is we still have to figure out the quantity, huh? Hey, Mr. Wormhole, you can actually see exactly what I'm using if you go to the dig.siegegames.com link that Nightbot just posted. I use SDL with BGFX. And then you can see everything else I'm using here. Yep. If you have any other questions, you're welcome to ask. Okay, so we're just adding this in so we can actually see the data and know what's going on. So this is const. It doesn't like me. Oh, it's because I can't make that const. I guess I still have to do a conditional here, which sucks, but oh well. Cause what we need to do, yeah, we basically need this. It's too bad. All right, so we'll say, hey, that's the quantity. This is the flow X. This is the flow Y. And that's it. And if we wanted to, we can add in another one, which is like none. If we just don't want to see it, but maybe we'll do that later. So then what we can do, the last thing, is go into here, and we have access to that already. So we'll just say that if the player ever presses a button, specifically like maybe we'll say C right now. SDL key down and event.buttons.state is equal to SDL pressed. Then we will take our automata liquid. That's the component. And take the display mode. And this is where things get a little awkward because I kind of wish that, like, this is a class. Maybe we'll get rid of that. And so this can be 0. Well, it'll default to 0. But if we do that, then we can take the display mode and set it equal to the display mode mod 3. Maybe we want to actually add in the count here. So then we mod liquid display mode count. That's annoying how you have to liquid display mode. Should work. This isn't const. Int cannot be assigned to an entity of type blah blah blah. This is one annoying thing about enums. I think I need to say it's a uint8. And now it doesn't like. Oh, maybe what I need to do is cast it and then, or bind it like, yeah. Why is this not working? Oh, maybe that's why. Liquid quantity is undefined. Yeah. I don't know if I have to. I think maybe I need to do it like that. Does not like that being an int. It's because they're both. I specify it as a uint8. Yeah, I think it's like you can't do it if it's a class. I think that's the problem. Like if you make it a class, I don't know, it's enums are in such a weird place. I feel like they're so weird in C++ because they're like numbers, but you can't treat them as numbers. This is like, I want to do this, but I can't because it says that I can't convert an int to and oh, whoops, I'm dumb. Maybe this is why. I was trying to cast it to the wrong thing. I do feel like ints are kind of in this weird. I mean, enums are in the weird place. Can I have this still be a class? Yeah, like here you can have it be a class and do something like this. So you have to say, well, it's not an enum class. Make them structs. I mean, it's true. I could just turn them into something completely different. Okay, I think this will work. Oh wait, I forgot one thing, which is to say and the event. Oh, I can't say button. I need to say key. Key type. Key symbol. I forget how this works. Okay. There we go. So, or I didn't want, I want C, that's right. Don't you mean I do, thanks. That is important. We're not gonna make much of a difference if we're just modding the number, huh? I got caught up on that whole like enum thing. Thanks. Enums, well, they automatically get assigned a number. So that's one really nice thing is that you can like rearrange them, and they automatically just have the number being incremented. So it's like 0. It starts at 0 and it goes. But you can like if you set the first one to 5, then it would be 5, 6, 7, 8. So they just get assigned. But you can also assign them a number if you want, and so it's like it takes care of some of the management for you of like, yeah, specifying stuff like that. Okay, so if I press N or C, we can see those different numbers. Cool. So, okay. Why is it 1640? I don't completely understand that. Yeah, this is like super wonky. I think one of the problems, maybe, let me look at this. No, I do set it to 0, 0. The negative kind of messes it up. So red is flow X. That's one thing that kind of sucks about this is I have to remember what they are with the different colors. So flow X is red, flow Y is green. So this is the flow Y. So we can see it gains some speed as it falls. Let's restart this. Maybe what I'll do is I'll actually set a breakpoint over here. This is not working quite right. I'm missing something. Oops. So let's see here. What's the flow Y? It's 4. Why is it 4 though? Because while it was falling, what's going on there? Shouldn't it be adding? Or is it because of this? Oh, you know what? I think I might be doing stuff with the above cell and that's kind of screwing things up. Ah. Yeah, so part of the problem is that we need to say that the below cell gets 4 added to whatever it is, right? So why is it... What must be happening is that it's always just doing this other one. Okay, what's the scenario? If the above cell is greater than or equal to the current cell, then we take whatever is above it and we put it into this cell. So that's pretty much the same as this. So I think what we want to do is, and we actually will decrease that. I see. That's why it sometimes gets to -4. I see. So I think we need to put this in here and change below cell to just be cell. And this needs to be above cell. Okay, so now what's the flow Y? It's still 4. Okay, let's try this again. And step through this. If the flow... of cell is less than. So it's at 0. So we add 4. So this cell, which is below index, is 1428, gets added 4. Oh, I think I see what's the problem. It's because it never transfers it whatsoever. I should have realized this. So it's like what we need to do is, I think we need to say that it's the current cell plus 4. And then I think we need to add to that. But we also need to say that if the quantity is ever 0, the remaining quantity within this cell, cell quantity is less than the maximum amount. Yeah, we kind of, I think that's like one thing we need to do is to say, like, if we ever hit a cell that has 0, I don't know if this is what we want. I think this will work. Just like say, hey, the cell flow x should be equal to 0 as well as the flow y. I don't know if this might be wrong. What we might want to do is have a check at the end or something. Hey guys, sorry I was a little focused there. Is all created and Baxter and critical Owen and simple. I don't want to bother you with too many questions regarding Korea. But I tried to make a multiple shield decors and thought it would be as simple as copy pasting decor.pngs and decor.ce and name them something different, and then make a new texture for each one, but the game only picks up the original shield decor, of course. You probably need to change some stuff in the decor.ce file, likely the name, and that might be it. Might only have to change the name. I'd have to look at it. But yeah, that should be it. You probably need to change the name. Okay. So let's change this here. Oh wait. Oh yeah, this needs to be above cell. Plus equal. Okay. Let's try this. So now it says it's 4, or this is 0, 0, it sets that to 4. And then we go to the next one. This is 4, so now it gets to, it'll be 4. Oh, this is 0. Why would that be 0? This is 8. Okay, that's right. 0, 12. This looks like it's right now. Then it flows down. Now it's capped at 64. That's good. it will then say it's greater than, it splits it, so now it's 32. It says, okay, now we have a negative 32 and then 32, and that looks better. They seem to always go to like negative 32. Okay, so this is definitely wrong. It also gets to be very large numbers. Wow, this is so wrong, guys. It's like just going crazy now. No, I broke it all. What is happening? I think I like screwed it up and it's yeah. It's not exactly what we want right now, huh? I think it's likely because of how we're like adding things together. And so it's like things are just like moving much faster or something. Right? I think so. Like here, maybe what we want to do is just set it equal. Maybe we don't want to set it equal. Maybe we'll try doing something like that. I don't think this is quite right either. Y, low X. This is if they are not the same sign. Pick the max between those two. That should be fine. Hey Bart, how's it going? I have to like slow it down so I can better see what's happening. Whoops, accidentally closed it. Like, why are these at 32 and why is it not decreasing? Should flow left. There's the quantity. There's the remainder. The flow is 32, so it says, okay, let's move it. Okay. Yeah, I guess that makes sense. So what are your plans for the automata system in the long run for the game? I'm trying to get flow and pressure working. I actually had pressure more or less working, and then I broke it with the flow. But I do have the pressure committed, so we can always revert back if we severely break things. Yeah, I feel like the flow implementation is way too complicated right now. But anyways, beyond liquid simulation, I would like to also have temperature being simulated, as well as fire, and perhaps even some sort of like pollution or waste that can spread. Um, and then having those systems tied alongside or tied together with a lot of the other aspects of the game, such as fire can actually like catch things on fire. So if something like items will have this like flammable um, aspect to them, and so they can be caught on fire, or maybe they can be resistant to catching on fire. So water would be resistant, while oil would be flammable. Uh, and then stuff like um, fire increases the temperature. Um, Same with lava. So those systems kind of working together, and so on. Um, so that way, the the game systems are all kind of like feeding into each other, and hopefully that leads to a more emergent gameplay. That's the goal. So it's kind of like, in some ways, it's a simulation game. Yeah, okay, so I see what the problem is that now, since the flow X, we're never decreasing it. I was thinking like it would keep flowing and then hit the wall. Emergent gameplay is always fun when it works. Yeah, it is tricky to get working right. Um, I think between the cellular automata and the physics with the automation, where like players are really encouraged to build things and they really care about the environment because they're building things, but then they have to work around the cellular automata systems, fire or lava or oil or temperature. I think that will lend itself very well to the more like emergent gameplay, where it's like, oh hey, I have this like item I'm trying to fire across, and maybe like it lands in some water that like does something to it or whatever, that it then like gets moved along in some current in the water, where like we have fans in the water that's like creating some sort of like flow or something. I don't know exactly how that would work. I don't know if I'm going to do buoyancy in the game. Maybe we will. Maybe we can have buoyancy. Yeah, I'm not completely like some of that stuff. It sounds cool. I don't know how well it's going to work. Like, it'd be pretty cool to be able to actually have flow where it's like moving. Like the flow can affect the items that have buoyancy. Buoyancy is easier than flow and pressure. Um, yeah, but that's like outside of this. It's easier because it's outside of that system, right? And all flow would be is like, well, buoyancy is like, hey, if the item is underwater, then have it float up, have it move upwards, like kind of anti gravity, right? But then you could just say, hey, let's instead take the flow and apply the flow. We have the flow X and the flow Y, so you take the item's position or whatever, the tiles that it's overlapping, you get the sum of all of the flow, the cell of all the flow X and the flow Y, and then you can add that to the buoyancy velocity, and suddenly you have flow with like or the flow affecting the buoyancy item. So suddenly you can be pushing items around, right? How are you doing liquid pressure? In Starbound, I cheated, and water is actually a very heavy gas. The pressure right now, how it's working is that um, it's mostly right here, I think. So like if a cell is um underneath a cell that's already like full, then what it will do is it will pull down some of the liquid from the full cell, and so it kind of like compacts, and so that way, like if you look at it, the you'll have it where it's like the full cell is 16, so it'd be like one is 16, the next one 17, the next one is 18, 19, 20, and then they're always trying to spread out to neighboring cells that have less. So if you have one cell, like if you have like a huge tube um that's like stacked very tall of water, and then you have a little hole at the bottom, and then you have like a little section where it can flow out. You're going to have it so that it's the kind of build up pressure quantity lower, and so it'll try to escape through the hole. So basically a gas. I mean, yeah, I guess so. I don't like. I was trying to put the pressure inside of the quantity, so that way I'm like, I think it just worked out and made a lot more sense. It's okay. I don't really know, like, to do a more complicated pressure, it would require a lot of work. We kind of talked about that yesterday. Um, yeah, I don't know. So right now I'm trying to do flow. Did you guys do flow for Starbound? I'm trying to get it down, but like I'm not sure about this current implementation. It's just like it's ending. I think in theory it could work, but I need to like take a step back. Flow is like the velocity of the water. So let's say like you know so basically like water can have gravity applied to it to some degree, and so you could do things like there's no directionality or inertia. Yeah, exactly. So like if you actually get it working right, you can have this like idea of like a waterfall, like I kind of illustrated over here, where like it's hitting up over here and then it's kind of bouncing off, and almost all of the water would be going this way and very little or no water would be going behind it, even though like in most games it would equally just fall down and equally go out. um but if we have like this concept of like flow or inertia where it gains movement as it's flowing downwards, so it has vertical velocity or inertia, and then whenever it hits the ground or water or whatever, some other like thing, um, it will then spread out. It'll take that vertical velocity and split it, and or like convert it into horizontal velocity or inertia, where suddenly now you have like, hey, now it's like firing off here, and so if it like falls really far and it has a really high velocity, then maybe it won't even like fall at the initial next tile. It will like move over more. um Yeah, I'm trying to get it to work. I don't know. I might just kind of scrap it for right now because it's not super important. It's like it would be cool to have it in the game, and you could definitely do things with it. Like the buoyancy thing I was talking about, where you could have the flow be affecting the item, or you could have it where like the waterfall, like the water actually, since it has some sort of inertia or velocity, you can kind of guide it in different directions or whatever. Are you doing tricks like visiting cells forward one frame and then backwards the next frame? um Yeah, I don't know if I'm actually doing that right now. Alternating. Yeah, I'm kind of. So right now it's alternating, kind of. Um, it is alternating which cells. So it's doing like a checkerboard right now for the cell. So it always starts on the bottom. I think, oh, actually, wait, no, it doesn't right now. I was going to change this up, but yeah, basically it updates it as a checkerboard, using this alternating thing that I have right now. But I'm gonna be changing this some anyways. Yeah, I don't know about this flow. I think I'm about like ready to scrap what I have right now. It's just the problem with it is that it has added a lot of complexity, and I prefer to try to keep this code simpler. That helps the cascade to neighbors. Yeah, right. Oops. Yeah, I had that problem in Korea. Yeah, we have some of this weird stuff where it's like stacking. I don't know. This isn't working well. I think I'm going to stash these changes and maybe do something else because I don't like this. CA flow. Yeah, I don't know. I need to take a step back and I think reevaluate how I really want to do that flow. It was just getting too complex, I think. And this is something I need to make sure I don't like. It's cool to try to, add stuff like that, but it's also not like extremely important right now. I think it's something that I could always add in the future. One cool thing is that, it's very localized, so it's like, oh yeah, it's all of the code would go into this function basically. So we can see this is the working pressure. So we can stack this up. Whoops. Stack this up a little bit. And we can see I forgot I had that one change I need to add back in. So we can see it's actually like, see how this is 16? It's because we're moving like a bunch of quantity over every single frame, so it's slowly draining out. If we remove that, oh, that's interesting. I wonder why it's not spreading out over. Oh, it's because it wasn't empty. I see. That's why. It was lying to me. But yeah, it's pretty cool that we can do that. So this is the working pressure. The one thing I did want to include in here was this change with the height. Just take this height. Fix that. Okay, so let's jump over to our roadmap here. So we're looking at Cellular Automata, and we have the water working, and technically, like, lava and oil are going to be pretty much the same. Okay, now we got that working nicely. Good, 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 good. So yeah, I guess there's actually one problem here, which is that we have that whole bouncing thing that I was hoping that flow would fix. But since we're kind of scrapping flow, then we need to figure that out. Which is that whenever they settle, we'll let it settle. So we can see now it's like bouncing back and forth where like these are 13 and 14, 13 and 14, 13 and 14. I don't like that. I don't really know the best way to go about trying to solve that. Technically, it should be flowing. It's probably fine to have them bouncing if you smooth it via shader, right? Well, the thing is that I want it to be able to go to sleep. And then there's also a slight problem where technically, like, these are higher. You can see it still has this issue, like this is 16 over here, and this is 11. And so one thing is that it should be bouncing or slowly going over that way. But because it's like there, if it will like let them bounce. I don't know. It's like I guess what I need to do is say maybe kind of like what Bart said was like add in some sort of like this very simple concept of flow or like a bias where it's like, hey, if you move the quantity in this direction, like the single quantity, then don't allow it to move back in the previous direction. I think this is the result of doing it in a checkerboard. Yeah, I think so too. But if we remove the checkerboard, we end up with other problems. Like we can remove that just by cutting this out here. Oh yeah, you can also see it like bounce, like it kind of moves really quickly because it like is updating twice. Let's see what happens. Yeah, that does smooth it out. I mean, kind of. We still can end up with no, we still end up with something like this. See, like this is an 8 over here and this is a 2. That should not happen. But yeah, I think it's the bias is probably the fix. Where we just say like if it's trying to move, because right now what's happening is that I think it's still swapping them. It's just that it swaps it twice. And so you don't actually see it swap. It's like you get cell 5 and it says, okay, I'm going to move this one extra quantity over to cell 6. And then it gets to 6 and it says, oh, I'm going to move this extra quantity over to 5. And it's just like bouncing back and forth. Some of this might actually be fixed partly if we make it so the one extra remainder goes to the right. Let's actually try that. That might help because we give precedence flowing left over right at the moment, which is part of a problem. I mean, that's kind of a problem. But if we do it equally, maybe that will help. So we just want to always have it be doing the whole pressure thing right now. Actually seems to help a lot. Nice. That actually helps a lot. Should have realized that. So like we give precedence to the right cell in one way, and we give precedence to the left the other way, and so it kind of balances out while still being completely deterministic. Let's add this back in. Do you have sleeping coded in yet? Because if so, you could make sleeping cells turn red so that you could see if it's happening. I do, but I don't track that state. Yeah. So we can still see it bouncing back and forth. But it does even out, which is good. Yeah, that's pretty good. That actually fixed a big issue. That's nice. It still can bounce back and forth, which is something I would like to try to fix. I just don't know what to do about that. Does it even from left to right as well? Oh, we can try. You're talking about just like doing this. Not quite, huh? Yeah. There's you can make it so that there's a 2-unit difference between cells in order to transfer. Yeah, but then you could end up with this like staircase problem still. I mean, we still kind of have that here. Wouldn't it stop the bouncing? Yeah. Yeah, so the problem is with the bouncing is that there's exactly like one extra unit that one quantity that's trying to share between two. And so it keeps going back and forth. Um what can we do? We could do something like a bias where we say how would that work though? If it's maybe if we move more than two quantity in a certain direction, then we set the bias to be moving in that other direction. Um, and I just don't know how it would work. I almost feel like what we have to do is like track the extra quantity. Yeah, we still have this whole like stacking thing. Like, I guess that's the problem. I think what we need is like, if we have a bias, maybe that's what we would do, is some sort of thing where like, where we would set the bias for the tile that we move the cell into to be one way, and then set the tile or the bias of the cell that we were moving from to be in like an opposing way, so that way like it won't ever move that extra quantity back over. I think that's probably what we need to do. So like, depending on the direction it was moving, that's where the extra quantity goes. And yeah, maybe that's how we can fix it. Which is, yeah, I mean, we could use like the flow. Let's see here. So how would this work? Thinking here. So if we have a left cell, we could say that the flow is equal to -1. The right cell could be 1. And then the current cell is 0. Maybe we would actually want to have it be different based on like, oh wait, I think we would need to factor it in here, right? So if we have a remainder, what we can say is if the remainder is equal to 1, then what we want to do is say if the cell's flow is, maybe we'll say if it's greater than or equal to 0. I think this will work. Then we'll flow right. Otherwise, oops. Let me actually paste this back down. We will flow to the left. If we have exactly 2, then they're evenly split, and that's fine. And then we update it so it's like this. So we say this is -1, this is 0, and that's 1. And then if we're flowing left, I think in this case what we would want to do is actually should flow left. We'll say if it should flow left. That's actually a little tricky. What do we want to do with that? We kind of need this like precedence where we say if the cell is -1 and we can flow left, then do this. If the cell is flow right, that's ugly. I think we might need to refactor this code out. A half cell, neither have a half cell, then they get a half cell, and the one value disappears. And if there's one with the half cell and one without, the one with the half cell keeps the one value. If both have a half cell and they both lose the half cell, and the value of both goes up by 1. The value of 1 should only go up by 1, right? Because if they both have a half cell, that's only 1 value. But yeah, I see what you're saying. Yeah. Maybe that works. That might be a good solution. I don't know. I would have to think about that more. I'm not saying it's bad. Haven't thought about it that way yet. Oh, I see. 2 half cells plus 1 cell. Yes, I gotcha. Yeah. So if they both have a half cell and there's an extra remainder, or there's a remainder of 1, then they are split evenly. Yeah, okay, I gotcha. I still don't think that would solve this problem of where they can have this like staircase, which is what I'm trying to solve right now. Well, I mean, I'm trying to solve both with this whole like flow. Oh, I just realized I think flow is a uint. That's gonna be a problem, huh? So yeah, I'm trying to think of this whole like precedence thing here. Problem is that this is kind of ugly. I think I need to pass in 5 values in here, but I think that's what I want to do. I guess actually I don't want to expose it, never mind. We'll just copy this here. Void update neighbor. So we're gonna have the cell, liquid, cell, liquid, cell, neighbor, automata liquid is this. And then we also, we need the index. M32 index, and neighbor index. Okay, so the reason I finally decided to split this up is because I think what I want to do is have this like precedence thing where we say if it should flow left. I don't know if this is the best way to do this. It should flow left and the cell flow is... Hey Jeremy, what's up? The water's going all right. Kind of aborted the flow to some degree. Yeah, it's tricky. And the cell is, I would just say less than or equal to 0. Then we can flow, which would be cell, left cell, index, left index, and that. And then that's it. And so then we can say, and the flow is equal to this. I think this is okay. And then we actually need to just do this again, but remove this. Right? Does that make sense? So that way we give the precedence to the flow direction. Oh, we definitely need to update that to be right. Right. I don't know if this makes sense. Oh, and we need to update the flow in here, right? I might have this 0 thing wrong. Or maybe that's where it would be impacted over here. Based off of the remainder, right? I guess that's it. We need to say the cell flow. We actually, I think, need to pass it in here, the flow direction. That can just be a name. Flow direction. Maybe we'll say flow. So the cell flow should. Actually, I think we need to say if the cell dot flow is equal to. This is where things get a little tricky. I think it's this. I'll think about it for a moment. It's something like this. I might have that a little backwards. Neighbor cell flow is equal to the flow or something. It's along these lines. Yeah, we'll think about this. We'll come up with an example and kind of walk through and see if we can make it make sense. Yeah, Jimmy, how was your coding last night? Sorry I had to run off. Like, that time of day is super busy because daughter is going to sleep, so we have to like do all of the nighttime ritual, and then right as we're putting the older daughter to sleep, the younger one woke up, and so I was like, oh, now I need to go on baby duty. Gotta go take care of that. But anyways, anyone know first good programming language? I always recommend Python. I think you've heard me say that before. But yeah, I hope you're able to finish it up. Get that figured out. Okay, so what I want to do, let's see here. Let's kind of work through this. Let's say that we have these two cells. And flow is 0. Or let's say maybe we need 3. So let's say that we had some water move into this cell and it gets to -1. And then this would spread out, so it wants to move over. This would become a -1, and right now this would become a 0, right? And then, so if we are saying that the flow is -1 that we are passing in, then let's see here. The current cell flow is -1, right? So we would pass the quantity over to the remainder. Yeah, that makes sense. That the flow is equal to the flow. Right. So this was a -1. And so if we had an extra quantity here, it'd be passed over and it would say this is -1. And then what we'll do is we set this to a 0. And so then if the next frame, it says, hey, I have this extra quantity, where can I put it? If it's checking the right, so the flow is 1, it's going to see that, hey, this cell is -1, but the flow is 1. So then we're going to keep the quantity on this cell here. It will allow it to go left, but it won't allow it to go right, as far as the remainder goes. I think that makes sense. Oh, whoops. I forgot to pass in here. So like this should be -1. This is 1. -1. This is 1. Yes, Soul Foam. I'm like, you've been around. Sometimes it's hard to remember, exactly who's who and what they've done. Okay, let's get back, build that again. You need to put the kappa in there. Okay, let's see if this is working at all. Eight, 7, 6, 6, 5, 5, 4, 4, 4, 4. That's not quite right. I mean, that looked better. Okay, that actually seems pretty good. For the most part, like, this shouldn't be a 15. This should be a 14, but besides that, it's pretty good. Yeah, let's see how this is working. How this... See, it doesn't bounce anymore. We fixed the bouncing. That's awesome. Yeah, I think this actually works pretty well. So the flow right now is just really more of a bias. It moves more slowly now. Well, part of it is because for a little while I wasn't doing the yeah, like I wouldn't worry about that too much. The speed is not a big deal. Sometimes though, okay, so that's still acting weird. That's weird. This is like a complicated scenario. I guess we kind of need the flow working with the X and Y as well. Like that should just stay as 17. I guess it has one extra. It's like all of these cells. I think it's because there's like that combination. Are you only biasing horizontally? Yeah, that's right. Um, but like we could always speed it up in many different ways. Due to the pressure, you'll need vertically too, won't you? Yeah. Yeah, you can end up with cases like this. Where like this wants to be a 19 and this wants to be an 18, but they can't exactly. I mean, they technically should. Yeah, I guess it's the same deal, right? Like what really should be happening is that it should pull it down, but it can't. Yeah, we need to do the vertical biasing as well, which would happen right in here. But that kind of breaks our current thing. We would have to change it some. What I would say is that it should be on a whole separate in that particular case, you could let it flow diagonally and that would fix it, wouldn't it? I don't. I think it was like a combination of things. Flow horizontal. No, I don't think in that case it would have worked. I'd have to pull it back up. This solves the majority of the problems. One thing I was wanting to do is change how we're handling this actives list. And see if that makes sense. So pretty much, and I talked about this yesterday, is that right now what we're doing is we have this list of cells that have changed. And so like if we move one unit of liquid over to another one, we just say, hey, update this. But what I would like to do is have this concept of segments, and we're updating segments. And we would just track which segments have changed and then update the entire segment. So it's kind of in between. So like there's one way that you can do it. Like the far left would be update all cells always. And the far right would be only update cells that have changed. Kind of in the middle of those two is only update cells that have changed, or update all of the cells that have changed within an area. So it's kind of like a dirty rect where we're like, hey, in this area, this has changed, so we need to update it. So instead of having this actives list, what we would have is something more like changed, and this could be like segment IDs that that have been changed this frame, or this generation, more of. And so then, yeah, we could just iterate over all of those. And so what's a segment? A segment is a 16 by 16 section of the map. We do this for the tiles where we break the map up into segments. So we just want to do that same thing here. And so in the HPP file, what we want to do is change this so we are calculating the segment ID and based off of the index. And actually don't think that's quite what we want anymore, huh? We probably want to do something more along the lines of passing in the X and Y value here. Because we're going to have to split, oh, that's, never mind. I guess this is okay. Because we need to take this and split the index up based off of the segments. So... yeah, that kind of sucks. We have to do this extra math here with the map width. So this is the number of cells, but then we have to like divide that by the segments. And then, and that's the segment count. Whoops. I prefer not to have to do that every single frame. Maybe we can just store it in the map width. We'll probably end up moving that. We'll just put it here for now. But we could just store that in here. That's not that big of a deal. So we have the segment width. So what we need to do is take the index and divide it by the segment width, I believe. And that should give us the segment X value, right? I think this is right. I typically don't do it this way. And then I believe it should just be segment X plus the segment Y times size segment width. And this is the segment ID. And then, yeah, I guess we want to copy that. All right, segment ID. So with our segment ID, we can push that in. And then we need to say, hey, if the segment X is equal to 0, then we want to say segment ID is equal to, and I guess technically we need to also check this, the index mod. The map width is not equal to 0, right? Or we could do it the other way. No, this is fine. So basically, like, what we're doing here is, you know, we have our world split up into segments. I was saying that this red square is a segment. For the majority of the tiles, we only need to add in the segment ID for the, like we're needing to add in the neighbors as well, activating the neighboring tiles. So if we change one tile, we also want to say that, hey, the tile needs to be kind of woken up as well or activated. And so most of the time, like, you know, let's say that we activate this cell right here, we then need to update its neighbors here. But if we are on the edge, such as over here, then we need to update neighbors that are not in the cell. In the segment. So we need to say now suddenly, hey, this neighboring segment is dirty as well, or it needs to be updated. But we also want to make sure that we're not on the edge of the world. If we're on the very far left and there are no segments to the left, then we don't want to say that that segment needs to be updated as well. So segments to the left and to the right are just -1 or -1 respectively. So yeah, we just want to do this. And if that's not the case, then we'll check the other direction, which is going to be if it's equal to sizes segment -1 and the index is index +1 is less than the map width. So basically we're not on the last tile. Then we want to add 1. And we need to do the same for the y. So if the segment y is equal to 0, then that means we need to move up. But we need to make sure that the index is greater than or equal to the map width, as meaning we're not on the top row. And instead of subtracting 1 from it, what we need to do is subtract the segment width. If the segment y, this is fine, and the index this could be done easier because it's 0 based. If the index, I think we just want to say plus the map width. Oh dang, I totally got this screwed up here. Actually no, this is all okay. Map.width, that's fine. It's right here. This is the one. If the index plus the map width is greater than, I think I want to say greater than the cell size, that means that we're on the bottom, right? Yeah. So it needs to be less than the map size. Yeah, that's right. And that's going to add the segment width. Okay, so now that should work, and that's tracking things with segments instead. Yeah. Hopefully that makes sense and is good. So we're no longer, wait, do we want to do that? I guess we do. We still want to track it, like say segments. And this is going to be segment or changed. Right. So this is changed still. So this is the segment ID within the changed. And so we still need to calculate the index, but the index is going to be calculated differently now. We're going to get rid of this. Get rid of that. Yeah. So what we're going to do is say for offset, right? I wonder what would be faster to have 2 loops. Probably not. Offset is less than. I think really what we just want is sizes, segment. I think I'm gonna put a constant here. Last segment value. So then we don't have to keep doing this. And yeah, over here, I was thinking about doing kind of the same thing, where we can say, segment cell count, which is the segment times the segment. So we iterate over the entire thing. Indent that. And then we need the index. And so, oh, whoops. I guess this isn't really offset, right? This is like, maybe we'll say segment offset is going to be equal to the segment ID plus some value in 32T. So we need to figure out like the offset. So basically, this is one nice thing about this is that we don't need to be tracking like the individual like cell positions or anything. We just track this one value and we can figure out exactly where it's at in the world. Because like, you know, segment 0. So yeah, we're splitting the world up into, I wish I had like a good way to really show this. Think of it as a big grid, and inside of each grid it's 16 by 16 cells or blocks. And so the first one is 0, and so if this is our grid here, this is our world. Let's zoom in a little bit. Let's just say it's something like this. Whatever. Doesn't matter. It doesn't need to be perfect. So this is 0. That's 1, 2, 3, 4, 5, 6, 7, etc. So if we say, oh, we're at 7, all we just have to do to figure out this exact position is say, hey, let's, you know, get the segment X and Y, which is going to be, I guess, well, we don't even need to do that entirely, right? So to get the segment X and Y, we need to, what we would do is divide by the segment width to get the Y value, and mod the segment ID by the segment width to get the X value. And then to get the final X and Y, or sorry, the final index, we multiply it not by the segment width, but by the map width. So it would be something like the longhand would be segment X is equal to, we actually need to get this again. This is automata liquid. So we say it's the segment ID divided by, oh no, this is mod. Y is divide. So this is to get the X and Y for it. So that would be like, this is, these are the IDs. And so to get the actual like X and Y, so this is going to end up being like 0, 1, 2 and down 1. That's not a good 2. So it'd end up being, come on, a 2, 1. That's the X and Y. Hey Anzers, what's up? How's it going? And so then we need to like take that value, and to get the index, we're going to say, and that's what I was thinking, the segment, maybe I'll say like the segment index offset. That's what I was really thinking it's going to be. It's going to be the segment X plus the segment Y times the map.width. Automata liquid.width. So in this case, you know, it's oh wait, this is wrong. Segment X. I think we need to multiply all of this by the sizes segment, right? And this is actually wrong anyways, because these all need to be tile, blah. No. Okay, I think that fixes that. All right, so now this would be, in this case, 2 times the segment tile, which is 16. So 2 times 16, so this is 32 is the offset for the X. And then the Y value is going to be, so we could technically move these up here if we really wanted to. Segment Y is going to be 1 times the width of the entire thing, which in this case is 4 times 16. So it'd be 64 times, oh wait, I guess that's true, is that we've already built in this conversion, huh? Like this is already being multiplied by, is this right? Because this should be 16, right? Oh wait, no, sorry. It would be 64 plus 32. This is wrong. What am I doing wrong? That's 1 offset. If I'm not trying to figure that out. Yeah, so this is right. I was just getting confused by that, because really, I think it would make more sense if I just put this up here. Because then this is basically the X and Y. This is like, it's not really the segment, it's the X and Y values for this. And so yeah, this would end up being 16, but then we say 16 times the, hey, isn't that wrong? 16. Oh, no, that's right. It's right. Because we're 16 rows over. Yeah. Sorry. That makes sense. So we've gone 16 rows down, times 64. So yeah, that makes sense. Right. So this is to get the segment index offset. I think we might be able to do this a faster, more efficient way. I feel like it. I'm sure there is a way to do that. We'll figure that out. But the final index in 32T index is going to be equal to this offset plus the offset. And maybe we'll just change that to be I. Oh wait, that's not right. Yeah. Because what we need to do is actually... I guess what we could do is take the segment X and segment Y. Because we technically need to calculate this here as well, right? Where like dang, yeah, okay, this seems more complicated than I thought it was going to be. Because we have, you know, let's say what we're doing is we're going to iterate over all of these, and then we're going to iterate over all of these, and so on. And so we're just going through them. And row by row, but whenever we jump to the next row, that means that we need to skip over like all of these remaining ones over here. So it's like, it's a big jump index wise. Like we need to jump map width of cells, right? Every single 16, we need to jump the automata liquid width. Which is why it's like, basically we need to calculate this stuff where we say, oh, it's the sizes segment tile mod this plus the I divided by the sizes segment tile times the width. And so that's calculating the proper index. I feel like this is really expensive to do. And then here we're actually calculating that stuff anyways, which is the final index, which is kind of odd as well. Like we don't need to be doing that. We can definitely like, we want the index, but we're also kind of like calculating, you know, you can see that kind of here. This is, well, yeah, I guess what we could do is, so we have the segment X. Maybe what we could do is rename this segment start X, start Y, and then we can say that the segment X, so this is local space segment X, is going to be equal to this. So actually, let's rename I to segment index. And let's rename this to segment start index. This needs to be divide. Okay, so with that, then what we can do is to calculate the cell X, we just have to add them. We say, well, it's the segment start X plus the segment X. And same deal for the Y. And then the final index is just going to be the cell X plus the cell Y times the segment, the automata liquid width. Okay, cool. So that's it. That's actually it. Yay. I don't like this though anymore. What if we just did this twice? Yeah, I think that's probably what we want to end up doing. Could we do that here? No, we might want to do it for... I would say we probably want to do it outside of everything. So we'd say for 32t I equals 0, I is less than 2. So we just do this twice. Oh, and actually I want to call it something else. Oh man, these indents are getting a little out of hand. Let's call it alternating. So we're gonna end up getting rid of this. Right, so we'll just alternate 0, 1, 0, 1, 0, 1. So here now we can just say, hey, it's always gonna be either 0 or 1. So we don't need to do that. So it's just like we skip every other tile. And one thing we could actually do that would make a lot more sense is like we could cut this in half, right? And we could factor this alternating into this. So like one of the things that sucks about this is that we're doing a lot of work right here. Yeah, we could definitely fix that. So I'm gonna put a note here, which is to do instead iterate through half of the segment cells and factor alternating into the cell X and cell Y. Okay, so we'll do that a little bit later. Yeah, activate. I think everything else is good then. Instead, iterate through, wait, whatever, right? Iterate through half of, there we go. Don't know what I'm writing. Oh, whoops, actives, yes. I can read, I swear. Activate. So this will actually make it simulate twice as fast now since we're alternating. This, we can get rid of that now. Since we're alternating within the frame. Uh-oh. Actives. Yeah. Uh-oh. We got something wrong there. That index is very wrong. Segment ID changed. We're obviously pushing the index into that. We should not be doing that. Where is that happening? Changed. Are we doing that in game? No. Use Pegma once, yes. Okay. Let's see what's happening here. Segment ID. Wait, what? I think this has been calculated very wrong. The position is 2915. And that's being passed in as 3029. Segment tile. We have 200. Why not if and def? That's more of a C thing, right? I think Pragma once is more of the C++. I need to open the door. It's getting way too hot in here. Okay, so there's something wrong with this. That G++ would not support Pragma. I'm not compiling with that though. I think I'd maybe only use GCC. I don't know. I think that's GCC supports it. Pretty sure. I don't know. I haven't had any problems with Bangmo once. I don't know like what the compilers support and don't typically, but that's like a very small percentage of players, so I don't really care that much. Segment width. So what's up with this? I think it's because the segment width, see that's 12. Yeah, this should be the X and Y values, huh? That's my problem. Yeah, I think I can't pass in the index here anymore, which is probably fine because we're not even passing that in. So let's change this. Let's change it to be cell X, whoops, and cell Y. This should be cell X, cell Y. I think this is the proper solution. Hey Rohan, doesn't segment ID need to be times by the number of cells in X? It needs to be the segment width of the world. So this is the map segment width. I think this is right. Yeah, maybe the variable name is misleading. So this is the map width divided by the segment tile, which is the number of segments wide for the entire map. So now we need to go over into here and change all of this stuff, which sucks. Okay, so the below cell is going to be plus map.width. Whoops. Automaton liquid. And this is cell X, cell Y. So we're just having to like activate this stuff. Like I said, it sucks. So all the indices we can just change like that. That will make it easy. And then we have this refactored up here. This is going to, oh, we don't have the cell X and cell Y. No. Ugh. You can find all of the details on like the third-party libraries I'm using if you go to that link there, dig.siegegames.com. I guess I need to pass in the cell X and cell Y here, huh? That's not gonna quite work. Well, actually, it might. I guess it does. Because we can just add the flow to it. That's a little cheating. I don't know if that's going to really work in the future, but we might be able to get away with that. So right is just add 1. This is subtract 1. The above cell is going to be the same as this, but we subtract the width. And then this is going to be cell X, cell Y. The neighboring cell is just going to be plus the flow. And then now we need to say in 32T cell X, cell Y. Okay. There's a baby crying in the background. Sorry, guys. I was like roasting in here. Yeah, no problem. Let me know if you guys have any other questions. Index. Hopefully we don't need to worry about that. Oh, this is cool. So now we can, instead of an index, I guess we're actually calculating the cell X here. So we just want to say, hey, if the cell X, oh wait. Yeah, if cell X can't be 0. Cell X plus 1. Oh, whoops. This was wrong, but we fixed it here. What's wrong with SDL? Index is greater than the map width. This is wrong, right? Yeah, this was all wrong, but this actually fixes this stuff. That's good. Okay, well I'm glad that got fixed. Hey Monstrous, what's up? Oh. Okay, this looks better. Oh no. They're not moving. We broke everything. Okay, so maybe let's break in here. Changed is 1. Say it's 7. So this segment, maybe what we'll do is we'll continue. Wow, I like completely screwed this up. This is not right at all. Yeah, I don't use STL, I use BGFX, which is kind of sits on top of all of the other like graphics APIs, you know, DirectX, OpenGL, Metal. I think they're working on Vulkan right now. And I can kind of change which one I'm using on the fly. Like the game launches and it will like automatically detect, hey, if you're on Mac, use Metal. If you're on Windows, use DirectX. But I can also override that if I want. So I can say, hey, use OpenGL right now. Yeah. what programs do you use for game dev? Mostly Visual Studio 2019 and Sublime Text 3. And then Source Tree for Git stuff. Okay, so one thing I wanted to do really quick, go over to here, and whenever we insert this, I want to see what the cell X and Y are, which is 30, 14, and then why did it not update? Ah, oh, dang it, I thought I had a breakpoint there still. $28.16. 28.16. Okay, so this is definitely wrong. Because it's saying the segment start should be 64.16. So it's not updating the segments. So the segment ID that we're calculating over here is wrong. Okay, so let's look at that again. Where we can crash. What am I doing wrong here? Okay, so 28.12. All right, and it's 16. 28.12. So we really should just be at 1, 2, right? Why is it 4? Cell X is 28. Oh, you know what? I need to divide by the segment tile first. Yeah. My bad. I screwed this up completely. Because I had the whole index thing. I think the index would have worked if I was dividing by... Yeah, I was like kind of in between the two, and I was screwing everything up. So now that we have the cell X, all we just have to do is say this is the sizes segment tile to get the segment. Yeah. For both of these, it's just divide by those components. Okay. Yeah, I was like halfway doing the index thing and halfway doing the X and Y coordinates. And that was very wrong. That was wrong of me. I apologize. Okay. So now that's 1 and this is 0. That sounds a lot better. Yeah, that sounds a lot better. Except for it's still crashing. Why? What is the index? Why? What? 17, 224. How's the segment offset? Segment Y. What's the segment ID? Is 169. Why is it trying to... Where is it getting 169? I probably screwed something up over in here, huh? What? Where did I get that? Excuse me. I don't know where it's inserting the 169 from. Okay, so let's pin this so we can see where it's at. Wait, okay. 28 to 28. Oh. That's wrong. Cell above it. That should be... Wait, this is probably wrong for all of those, huh? Yep. Also minus the width. Should be right. I think. We still have a breakpoint over in here? Yes. Okay. That still is wrong. It's because we're adding... Oh my gosh. I'm so silly. That's the index again. Ha ha ha. That's right. We're working with X and Y coordinates, so I just add or subtract 1. Okay, I think it's about time I stop. Before I hurt myself here. A little silly of me. Yeah, I'm like... I started implementing it with the indices, so I was saying like, you know, hey, this is the index, so I need to add the width to it. But now I moved over to the coordinate system, and yeah, I was just like mixing the two, and that definitely causes some issues here. So we should see like at some point, like, yeah, see it says 12 here, but still counts as being in that segment. Okay, I think we got that. Oh, no, spoke too soon. What's the value? That should not happen. If the segment index is equal to 0, if it's equal to 0 and cell X is, wait. Segment X. Cell X. Oh, I guess I do need to say, and the cell X mod the sizes segment tile is equal to 0, right? No. We already have that. Sorry, that's not right. Shouldn't we just say mod the map width is equal to 0? Yeah, I think that's actually what I had before. Wait, do we really need that? I mean, cell X, isn't it just going to be 0? Wait. What am I doing? We want to say if the segment X is 0, that means that it's the first segment And sorry, it's the first cell within the segment. And it's not the first cell in the entire map. No, it should be, that's my problem. It needs to be segment x mod the segment width is not equal to 0. That's the fix. There we go. Had to think about that. If the segment x is the last value, so that's 15. Segment x. No, wait, no. X. Ah, isn't this saying the same thing? Maybe that's all I need to do is this. No, because I want to say that this yeah, okay. That's my problem. Is I was getting a little confused here. So this needs to be cell x is mod the segment tile. Sizes segment tile is equal to 0. Yes. And the segment x is not equal to 0. So that means that it's the first tile within the segment, but it's not the first segment, so it's not the leftmost segment. Or a leftmost segment. I think I need to get this and the stuff. We need to do the same thing over here. So this should be, man, I got this all wrong earlier. Segment x plus 1 needs to be less than the segment width. And this is supposed to be up here, which makes me feel like I should probably save that value. Maybe we could say local x and local y. So many variables. I feel like this is kind of crazy. Seems kind of crazy to me. Okay, so now I need to try to fix this down here. Wow, I got that so wrong earlier. So if the local y is equal to 0, as means the topmost cell within the segment, and the segment x, sorry, y, is greater than the map width, as meaning that we're not at the top. This is actually wrong. This needs to be segment width. So we're not on the top row. Then we can subtract. That makes sense. We could actually, in this case, just use the segment ID, right? Or we could say, I guess the other way to do it would be 0 here. One nice thing is that segment ID. We might be able to get rid of the segment Y. I don't know. We'll just do it like this. We'll say if it's not equal to 0, then we can subtract the width from it, because we know then that it's greater than the width. You know, actually, I don't like this. I like the other way, to be honest, because then it's clear, like, hey, we're making sure that it's greater than or equal to the segment width, and then we're subtracting. Like, those values are kind of connected. That makes me feel better. And then the last thing is local y is equal to the bottom value, and our segment ID plus the segment width is less than the segment. All right. Oh, what is that? That actually is harder to do, huh? We have to calculate a new value. We need the segment height in this case, which is the map height divided by sizes segment tile. No. Oh, that's if we are doing the y value, right? Yeah, that works. Segment y plus 1. Man, this is messy. I'll have to come back to it later. Hey, it's updating now. That's good. So what we could do is let's do this now, where we just one last thing, so we can actually visualize what is being updated. It's more of like what will be updated if we use the changed, right? But this will be fine. Only render cells on screen. Yeah, so what we probably want to do is like iterate through all of the, like do it by segments. But anyways, so we can iterate through the automata liquid changed segments. Hey, what's up?
My dad has offered to take Kaylee grocery shopping.
Okay, give me one moment, guys. Okay. What we want to do is pretty much this exact same thing over here, where we're iterating over the changed. And what we'll do is say this is the automata liquid changed. We just want to draw a rectangle around it, and it's going to be the sizes segment, which is pixels. So it's 256 by 256, and then we just need to figure out the x and y values, which is this is the and let's do like red color. Okay, so this is the segment outline color. I think I want to put this segment width on the map, so I don't have to calculate it every time. Segment start X, segment start Y. So I think we just have to multiply it by that, and that's now, instead of tiles, it's, yeah. This will always be like delayed by one frame because it's not the tiles that changed that or that got updated that frame. It's the tiles that will be updated, or the segments that will be updated. Yeah, so we can see it says it's updating this still, which is a little weird. It should settle. So it's like, what's calling? So that's interesting. So like this, we can see it has settled, but it still says that it should be updating this neighbor. And so this is actually like useful for yeah, seeing that it says that it's updating things even though it really shouldn't be anymore. The flow is -1. The cell flow is 0, which means that the quantity should stay on here. Oh, you know what? That means that nothing actually changed, huh? Maybe we could like optimize this. What would it be? Yeah, I think we can fix this up. So it's actually like nothing is changing. It's just it keeps saying that it should update. And so to fix this, I think what we just need to do is like say, hey, if the flow, what is this? In this case, it could potentially change them. And here we only want to do this if the quantity is going to be, maybe we'll say if the quantity is not equal to the cell.quantity, right? If the quantity is not equal to the cell quantity, or we have a remainder, then we will say that they should be updated. In this case, we only want to update it if they are not equal, right? I'm wondering if we could say, yeah, I think that should fix it. Because in this case, the remainder's staying on it, so nothing is really happening. Like, really, this diverges completely, huh? Like, we don't have to calculate the remainder in this case, right? Do we? Maybe we do. Oh no. What happened? I think I may have hit the bottom of the world. We'll look at that. Let's not let it leak out for now. What is still having it break? So quantity 7 and 6. So this is okay. We're going to push that over. Five and 4. Oh, wait, what's the flow? Shouldn't this prevent it from happening? Oh, maybe it's because it's... It should flow right, and the flow is greater than or equal to 0. Then it says that quantity flow is 0. This is 1. So it's going to keep it. Wait, what's the total quantity is 9? Oh, I'm silly. Ha ha ha. This was supposed to be happening afterwards, huh? Because we add it. Yeah, that's my problem. Yeah. Okay, I think that was the problem. Because it needs to be added. I'm saying, hey, if it didn't change. Or, if it did change, then activate. But, like, I was, like, not counting the remainder until after I had said it was changed. Oh, that's going to cause a crash, huh? Dang it. It still is not settling properly. Hey, that one did. Now it's not anymore. Yeah. Must be in here. Quantity is 2. That's 3. Oh, yes. Okay. No, I guess I do have to do that. I just need to say if the quantity plus this is not... Yeah. Ayo, there we go. Nice. What is it doing now? What it might be doing is the like stacking. Yeah, that's what I was thinking. Quantity is 0. Wait, cell quantity. Wait, the above cell is 14. If it's less than that, then we take this cell quantity minus that, and this is the quantity. And so we're trying to move the liquid up. I think I need to add in a check here, which is just, and the cell quantity needs to be greater than the max liquid quantity. Yeah. Could also add a check, like if the quantity. Oh, we're gonna get a crash. What happened there? Okay, so that actually doesn't seem to work. So what we'll do, say if the quantity is not equal to 0. I think it's because I was allowing it to go in 2 directions. That's the case for all of these, huh? I wonder if that's what I should just do. These are all the same, right? Oh, this one is a little bit different. Well, then we could just negate the quantity here, right? Here's what I'm thinking we could do. Maybe we'll make sure this works first. I'm gonna be heading off here in just a moment. Gotta get going. Okay, let's get it stacking. Looks like that's working. Oh no. Yeah, that stacking thing is something I need to work on as well. The flow, vertical flow. Hey, but we got it working now, so it's like, it's not updating anything more. So that's, it's pretty good. We do have that problem where like, see here, it's like, oh, that's weird. That those two are bouncing back and forth. Yeah, so it can still sometimes be off, but this is a lot better. So like right now it's not simulating, or right now it's simulating stuff. Yeah, like right now it's not simulating any of the Cellular Automata, which is pretty cool. So it's like basically free, sitting there. Well, it's coming to rest. So that's great. Yeah, I wanted to change one thing, and then we're gonna go, which is, I want to say, let's set the quantity up here, set it to 0, and then what we'll do is we will just set it here. I want to negate this because we normally are going to be doing this a little bit differently. So we're gonna move all of this down here. So you can see, whoops, if quantity is not equal to 0. So we have this check. So yeah, if it's not 0, normally we're adding it to the above cell and subtracting it from the bottom cell, but this other one, we are doing it the other way. So we're gonna gonna flip these. And then we can get rid of that code and we can get rid of this code. And we just have to set the quantities. And that's much cleaner. We're just saying, hey, activate this, the current cell and the cell above it. Yep. We'll make sure the whole like pressure thing is not working or is working. We can see it's like moving over here. Nice. Seems to be working quite well. Yay! Okay, so that's gonna be it for today. I think there's still like a few more things we can do to clean this up. We're getting close to being done. I think the next big thing really is that we're going to want to maybe do this to do, and then add in, and I'll put a note over here. Maybe here. To do is like, what is it? Add vertical bias, flow bias. Yeah, that's it. Just like what we did with the horizontal, so that way it won't keep having them bounce back and forth between the one cell and the cell above it. Yeah, cool. Well, thank you guys for joining. I appreciate it. Thanks for being interested and tuning in. I will be back tomorrow afternoon about the same time, and we'll try to wrap this up. And then we'll probably, I'm thinking, play around with some other Cellular Automata stuff and get that working nicely. Such as fire or temperature. Probably temperature is what we'd do next. Yeah, see how that goes. But anyways, yeah, thanks for joining, guys. I hope that you have a good rest of your day, and I will see you tomorrow. Take care.